Okay, so top left, you're like, the line fits, but the top right, you're like, the line fits?
No.
Not really. That could be better.
You guys, a line could not be better for that top right.
Yeah, like,
I guess half the
I
points
agree,
are probably
but
where
it just doesn't look very good.
You're saying that's a good line?
It's just not very aesthetic.
No, that's not what I said. I said a line could not be a better fit. Guys, what's the obvious feature of that one, of the graph on the top right?
Curvy.
It's trying its best.
The data's curved. Is everybody with me? Like when we look at that scatter plot, there's no question that that data is curved. It goes like this.
Yeah.
Okay. What about on the bottom left, the green graph?
I disagree.
Looks okay.
It doesn't look terrible. I feel like it could go down just a tad.
It's like that one dot is throwing it all off.
Mm-hmm. Since data do be like that.
Okay. What about the one on the right, bottom right?
I dislike it.
It seems a little weird.
A little weird.
Yeah, it's a little spooky.
It's like, yeah, it doesn't look right, but I could understand why it's right. It just doesn't look like it.
It doesn't look right, and I'm gonna refuse to believe that it is right, even though I know it's right.
I'm gonna sign.
Or I can use deductive research.
Okay. So, for this graph, first of all, guys, the equation of this line is y equals 1/2 x plus, I think it's 1/2 x plus 3 for each of these, okay? And r is equal to 0.85. And are you guys good with me calling this graph a good fit?
Yes.
Okay. This one, the equation of the line is y equals 1/2 x plus 3. And r is equal to 0.85. Are you guys, and we said not a good fit.
No bueno.
Aren't these the lines that were like the perfect, or like the best fit for the dots though?
It's the line that best fits the dots, but it's not the best model, right? Like if I wanted to find the best model for this equation, I'd want a parabola, right? So there is a best fitting line, but sometimes the best fitting line isn't actually the best model because not all data is linear, or there are certain things that don't quite make sense. Okay, so like when I look at this one, okay, when I look at this graph, I do not think this line is a good model. However, the equation of that line is y equals 1/2 x plus 3, and r is equal to 0.85. Because it is. Like I'm telling you it is. Okay, and I'm gonna call this not a good fit. Because when I look at this, I see this line with this point that might make me start to question what's going on. I'd want to know what happened at that point before I said this was a good model. And if I want to come up with the line that does the best for the overall trend of the points, that one point definitely seems to be pulling that line up, even though it's only 1 point. Do you guys see what I'm saying here? Does anybody want to guess what the equation of this red line is? Y equals 1/2 x plus 3. Its r value is 0.85. And this is true, like, okay? But is that the model that best predicts what's going on in this graph?
This looks like when you have a class full of like the same age and you're like, what height are you? And then you ask the teacher their height.
But not for this class.
Age, not height.
Age and height, the correlation.
Not for this. Everybody good? That's a better line. Okay. Now, what's my point?
Where?
Why would we talk about all?
Data is biased.
The line of best fit always, is it always the line of best fit?
There's a difference between, guys, really? There is a difference between what is the best fitting line and what is the best fitting model, okay? And what happens very, very frequently is we look at a graph, we assume it's going to be linear, and we just calculate the line of fit. And we say, oh, we got a pretty decently strong relationship with our value for R. We're good. But in reality, if we want to decide is a model appropriate to begin with, okay? Not is it the best, but just is it an appropriate model? The very, very, very first thing we're going to do is create a new kind of graph that you guys have never heard of before. That kind of graph is called a residual plot. Okay, here's what it looks like. I'm going to draw a residual plot for the blue graph. You ready? You're going to start with an axis that looks like this. And then you're going to go through each point, and you're going to say, where does it fall in relation to the line? So if I look at, say, this point, from left to, and we're just going to go from left to right, where does this point fall in relation to the line? Below. What about the next point over? Not just above.
On it.
It's like here, right? It's slightly above. And then the next one?
Below.
It's actually the one, this one's I think the next one. And then this one is just a little bit to the right of that and below. Do you guys see the basic premise of what I'm doing here? And then I do this one is below but practically on it. And then this one is definitely on it. And then this one just, and I literally am just graphing each point here and where it falls in relation to the line. All right, and this is called a residual plot. And guys, when you look at the residual plot on this line that fit well, how do you feel about it?
Pretty decent.
It's not bad at all, right? Or is it? Like when I look at this, how would you describe what you're seeing?
It's bizarre.
Okay.
Also, this graph just like doesn't tell us anything.
So let's look at one. Let's look at trying to make this one. Okay. This point is definitely below the line. Closer, but not quite on, slightly above, slightly above, slightly above, slightly above, coming back down, on it, below, and below. What do you see here?
Half circle? Yeah. Do these graphs ever have numbers on them?
But
They technically all do, but we not to the level that we're going to learn them.
it's like even, kind of.
Even, okay. Can we tell that it's curved?
Yeah.
Did the curve of it get magnified by drawing this graph instead of the original graph?
I think so.
Okay. With this one, we're going to see this. We're going to does that get dramatized? Do you guys see how, like, what the residual plot essentially does is it dramatizes any departures from linearity? Okay? Now, here's what the blue model has that the other ones will not have. It's a mess. It has no pattern. Okay, so if the equation we've found is a good fitting model, we should be able to make a residual plot and not see any pattern in that residual plot. Is everybody with me? Now, I'm going to make a different scatter plot real quick. Not of this one, okay? Just in general. Everybody good? This is just basic ideas here, okay? All right, now, if I calculated the line of best fit for this, it might look like this. No, it wouldn't. It's a little bit lower. Everybody good? How do you guys think about my line here?
Pretty good.
Looks pretty good, doesn't it? Let's sketch that residual plot real quick. This point is now like right here, yeah? This point, here, 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 here. Everybody with me? Did I do a decent job? Here's the deal. Do you see the curve in the residual plot that's way easier to see than the curve that was there to begin with? Human eyes, our eyeballs, are not good at seeing curvature that's not super strong. It starts to look linear because our brains are trained to look for patterns. Does this make sense?
Yes.
Okay. So if I want to know for sure, is something linear or not, what I need to do is after I get that line, I need to create a graph called the residual plot. So I'd like to show you guys how your calculator can create a residual plot for you. Does this make sense? Because that's what you are going to be expected to do when you do your project, which I'm going to introduce tomorrow. Okay, so go ahead and take the data and put it inside your calculator for these letters in Scrabble score.
Do you have a calculator I can borrow in the meantime while my instruction?
Check in the second drawer from the window. I'm sorry?
Is this week just a mystery in FST? There's nothing on the board.
Yeah, it's a mystery.
I'll see right now.
This one just doesn't work.
Just go with the flow.
Okay. So I'm going to type these in real quick. All right, everybody got it in? Okay. Once you have the data in, what you're going to do next is go ahead and calculate the line of fit. We do that by going stats, arrow over to calc. I'm going to choose option number 4. and hit calculate. And we get that in this case, I'm going to do this in context, we'll have that the score is equal to 0.783 times your number of letters
Do you do one?
plus 4.567. I'm sorry?
Do you do X is, wait, never mind.
Wherever you put the X numbers, that's what your X list is. Is everybody good? Okay. From here, when you think about that residual plot, okay, the X list is still going to be letters, okay? The Y list is something called a residual. You guys have actually been calculating residuals since we started working with scatter plots, okay? It's just that we've been calling them prediction errors, but prediction errors and residuals are identical things, okay? So if I want to, what I basically want to do is create a scatter plot of the residuals. Does this make sense so far? Okay. All right. So let me zoom in on just my screen here a little bit more. There we go. All right. So we're going to, if we hit second y equals to bring up that stat plot, what we want to do is we want to turn this y list into those residuals, okay? Is everybody with me? So second y equals brings up the scatter plot. Are we all good still? Okay.
What did you just say?
Second y equals is how we bring up the screen to control the scatter plot. Okay? So what we need to do next is put the residuals in for that y list. Is everybody good? All right. Now, the minute you came up with this equation, so you have to do that linear regression first, okay? The minute you did this, your calculator created a new list of all those residuals. Okay, so what we need to do is bring up the list menu by hitting second stat. And you guys notice my number 7? Should say resid. Is everybody good? I choose that. And then when I hit zoom 9, it'll make that residual plot for me.
Must have done something.
Yeah.
I don't know what it did, but it looks very strange. He's a good shooter. Is it actually? Do it.
Does anybody else have any questions on doing this on your calculator? Now, the second half of this is the model appropriate? What should we see on our residual plot if the model is appropriate?
No pattern.
No pattern. Is there a pattern on this?
No, I'm really.
So if I ask you, is the model appropriate, you would say?
Sure.
Yes.
Yes. If I asked you, why is that model appropriate? Because There's no pattern on the residual plot.
So whenever it's a syntax error, usually that's when you're typing the words, that's when you cancel.
Yeah, apparently I
I
just didn't push
want to be able to write down on here like how they do
Alistair.
it, like different things, and it's very complicated.
Are you going to
All right, there's something else I want to show you guys, okay? But in order to show you this, I want to go back to just having the regular scatter plot. So if I ask you guys to tell me, how do I get back to having a regular scatter plot on my screen? What do I need to do?
second y equals?
Second y equals.
Second y equals.
And then what do I need to do to that y list?
Change it back, or wait, go to list, change it back to y2.
We can just hit second L2 to get to that list. Okay, there's shortcuts to just like the basic lists by hitting second 2.
It's just residual that we have to go to that list
Yeah.
for.
Though if you went the other way, it'd be fine.
Then use zoom 9.
And then if I hit zoom 9, it brings up the scatter plot. Questions? What? Okay, from here, what we need to do is look at, if you don't like doing that residual plot thing, what we can do is we can go ahead and put the equation so that we can see it up against the graph. So if you hit the y equals button, we already calculated our equation to be 0.783 times the letters, which is our x, right? We can just type the equation in. For letters, I'm just going to use that x button. I just type it in. You with me? If I hit graph, I can see the equation with the graph, and if you want to sketch a residual plot from here, that would just be just as appropriate. Does this make sense? All right. So tomorrow, I will be introducing your next project. That next project's going to require that you get data that you believe to be linear. Anything you want, as long as it is linear. Okay? So a couple of you guys, like ideas you had on the last project that didn't quite work, might work now. Like especially if you had ideas that weren't going to work because of the 0, 0. We don't need it to be go through 0, 0 if it's all it needs to be is linear. That's the big difference between the last project and this one. So between now and tomorrow, I would start thinking through what you want to gather so that you can use part of the class period tomorrow to get started. Does everybody understand what I'm saying there? Like you don't want to wait until tomorrow to start thinking, because then if you can't gather your data, then that might be frustrating. So start thinking about what you want to do now. I'll do the exemplar for the first half of class, so that and then make a recording of it so you guys have it, and then I'll probably make it due by the end of the week. If not sooner, we'll see how you guys are doing. Questions?